Chemical engineering is using engineering principles to modify or control the chemical properties of a system, usually to make some product society needs. In many cases, chemical engineers work on systems in which chemical reactions occur, but sometimes it is the state or configuration of a material that is changed. One example is when separate phases of water and oil are transformed into what appears to be a single phase, as often happens when we make shampoo, salad dressing, or medicine. Another example is classical synthetic chemistry methods used to transform raw chemical precursors into high value-added products like gasoline, contact lenses, carpets, or dialysis membranes. Chemical engineers harness the power of nature and use organisms, tissues, or enzymes to perform the chemical transformations for consumers, such as using enzymes to make cheese or using genetically engineered organisms to transform biological feeds into pharmaceutical molecules. Chemical engineers develop processes and manufacture products that benefit our entire civilization, affecting almost every aspect of our lives. We work to make products safely and cost-effectively, and we ensure that our processes are energy efficient and environmentally sound. We create the fuel you use to power your vehicles and heat your homes, the batteries that store energy for you, the food you eat, and the packaging that prevents it from spoiling, the medicines that fight disease for you, the personal care products that keep you looking your best, and the clothing you wear. Chemical engineers also help create medical devices that improve your health, the coatings that protect your cars and homes, the strong, lightweight materials that go into airplanes, trains, and boats, the solar cells that harvest energy from the sun and inject it into the power grid, the microelectronic chips in your computers and smart devices, and the detergents that clean your clothes. And this is just a small sampling of the range of our impact. Chemical engineers work on all of these different applications using their broad understanding of the principles of physics, math, design, chemistry, thermodynamics, and systems. Chemical engineers are great problem solvers, and they do well working in teams on challenging projects. The skills they develop serve them well throughout their careers. The chemical engineering curriculum involves the application of problem-solving fundamentals to describe a wide range of chemical systems. You can't be a chemical engineer if you don't understand chemistry, and you'll take a number of chemistry courses, including lecture-style courses and courses that blend lecture with hands-on labs. You'll take a number of math and physics courses to round out your background, and then you'll be ready to jump into the chemical engineering core curriculum. In your chemical engineering classes, you'll use your problem-solving skills to track how mass and energy flow through chemical manufacturing processes, how and why chemical species partition themselves between solid, liquid, and vapor phases in industrial relevant systems, and what it takes to safely pump fluids through a piping system so they arrive at the right process step at the right temperature and pressure at the right time. You'll learn how to design and operate chemical reactors in a safe and efficient way so you can meet a worldwide demand for specialty chemical products while producing minimal byproducts, and you'll learn how to take a large number of individual unit processes such as reactors, heat exchangers, pumps, and mixers, and integrate them into an optimized, efficient system that produces desired products in a safe manner with minimal waste and energy usage. To cap off your experience, you'll work in partnership with your classmates to design systems that address some of society's biggest challenges. As a practicing chemical engineer, you can take these skills to almost any industry. Many chemical engineering students begin their careers early with internships or co-ops at well-known companies across a broad spectrum of industry sectors, including energy, pharmaceuticals, medical devices, personal care products, specialty materials, consumer products, chemicals and specialty chemicals, food and beverages, agrochemicals, and process control and control systems. One positive benefit of our broad curriculum is that students don't need to take specialty courses to join any of these industry sectors. Purdue Chemical Engineering graduates don't always join engineering firms. Many start their own companies or pursue additional professional training in a related field. For those students who do take a traditional role and enter the engineering profession, it's common for Purdue graduates to eventually migrate into middle and then upper management of the companies they join. Graduate school is another option, with about 20% of chemical engineering undergraduates continuing for an advanced degree, and they have great success at some of the world's finest chemical engineering institutions, including Purdue. Graduate study in chemical engineering leads to research careers in academia as a professor, in U.S. national labs working on issues of defense and energy, and in the private sector. Chemical engineers also excel in patent law and in medical school. Remember, the human body is one big chemical plant. Chemical engineering is a broad major pursued by a diverse set of talented students. Studying chemical engineering leads to rewarding careers that shape the world around us, improving quality of life across the board. If you like chemistry and math, and if you want a career that's always exciting and challenging, be sure to learn more about chemical engineering.